Good morning. Look, I'm worried. Linda is giving her phone number to everybody. Don't ask her for a date. Well, I hope you had a great time last night. And SolidCAM India, you are not only the fastest growing company, you are the fastest dancing company. I was talking to our SolidCAM UK guys in the morning. I said, what? You drink a lot of beer. Why don't you dance? He said, we drink. I said, the Indian dance. You need both, to drink and to dance. Anyway, before I start my lecture, it's a bit complicated, a lot of words, but you'll see something amazing. Before that, I would like to mention a few unsung heroes in SolidCAM. You have heard about our Chief Product Officer, Michael Vinetsky, but he has with him working great programmers. Gennady Goldgammer, where are you? Stand up. These are not only amazing programmers, they are team leaders of programmers. Ronen Shmatzion, stand up. He did the toolkit single-handedly. And Ram Polna, are you here? The guy with the black T-shirt is probably still sleeping. Now, beside great development, you need great QA, you know? If software has bugs, and it still has bugs, believe me, but anyway, there's no software without bugs. But we try to minimize the number of bugs, and we try to find out ourselves and not the customers. But in the end, some customers find bugs. But I could tell you, iMachining has been done so perfectly by Doron that I think there's no bugs there. Maybe there's a few here and there. So I have to mention the QA heroes. Our two veteran QA people are Tamara Dolgin and Lisa, stand up. Tamara Dolgin and Lisa Dobna. They started our QA, I think 30 years ago. They were, two of them, working with Doron. Doron was doing milling and turning. Lisa was checking the milling, and Tamara checking the turning. 30 years till today. This is the hardest work, working with Doron. and they know it. But they are doing still an excellent job going at it. They know Doron, and he knows them. So they work very nicely together. By the way, Tamara yesterday said something very interesting to me. You know, in the Soviet Union, they used to train even women on CNC. So we had many people who immigrated to Israel from the Soviet Union. They had studied CNC, which is not something you do in Western countries. Women don't study CNC. Anyway, so Tamara and Lisa had this background. So Tamara yesterday told me, you know, in the Soviet Union, we tried to make, the communism tried to make some international thing, get a lot of people from all nationalities together. They didn't succeed, but in SolidCAM, you succeeded. All of you, she saw all of you in all countries in the world working and dancing together, and it's a great achievement. So thanks to all of you from all nationalities. Now, beside the great pen, you had in your bag this amazing brochure, 56 pages. And we are not only the best CAM, we have the best brochure, 100%. Now, it's a recommendation and a command. Any of you salespeople, you visit a customer, you put this on his desk. He will never throw it away. It's too big. Doesn't fit. So he has to keep it. Maybe not on his desk, on the side, he has to keep it. So make sure you visit a customer, a partner, you have one of these. It's the cheapest marketing, cheapest. Print it and do it. And the guy behind our marketing for the last maybe more than 20 years, Leif Knittel, get up, see him in the back. You know, Leif has an amazing life experience. He studied in a machine shop. And then he studied some business, and then he started working in SolidCAM. He wrote the first manual for SolidCAM. And then he went into graphics and design, and now he has an amazing company called WebTemps. He does most of our marketing materials. Even you saw the pen video, the first one. So, an amazing guy. Okay, so probably Linda will be angry at me. I'm spending too much time. She's worried that we are not going to finish things. So basically, I ask every lecturer today to cut few slides, 5 minutes less, so that we can make up for yesterday. We have one more lecture we didn't finish yesterday. Okay, now to my own lecture. And by the way, Natalie sitting here relaxed. Do you know what she did yesterday after this boat trip? She went to a discotheque with the Tekias team. So now, with Ilkar and Yashar, so now, you know, when she asks Ilkar for 2 million, he has to listen. And this morning, Linda was not able to reach her by phone. She said, okay, we'll meet her at breakfast. She said, I said, forget it, go wake her up, she's sleeping. She was sleeping, okay. She doesn't have to give a lecture now, so it's okay. I have to do the work, okay. So, something amazing when I got the last report from SimData. You know, SimData, they are a very serious, the most serious market research company in the CAM industry. Very serious. Every year, they produce a book, a good book. And then, in this report, I saw in one place an article saying, the growing need for more sophisticated CAM. I said, really? There is more sophisticated CAM? Okay, let me see what they have. Where is my clicker? So, I'm going to show you verbatim everything they said there, and you will see everything they say they need for SolidCAM, we have it today. Let's continue. Okay, so what they say there, that, you know, we have shown this slide, that the market is going to grow in the next 10 years, more than 4 billion, covering all this subject we see on the right pie chart. They say that the anticipated growth of the car market over the next few years will continue to be driven by manufacturers striving to produce higher quality goods that can command higher prices and yield better margins. That's everybody wants to get. Good products that can command higher prices and yield better margins. Now, higher margins performance derived from producing higher quality goods and lower labor and life cycle costs remains the strongest business driver spurring adoption of sophisticated CAM software. That's why, you know, all your CNC machine shop will have to go on this trend of having sophisticated CAM software to be able to produce better quality goods. Okay, so to get higher quality and greater margins, they will need sophisticated engineering and machining. And this will require sophisticated CAM software, both for design and manufacturing. Another issue here, the scarcity of experienced engineering and machining personnel in most developed economies, all of you suffer from it. You can't find people. You have the need to capture knowledge and automate as much of the machining process as possible using CAM software. This is 3D eye machining, templates, this is the automation. All the feature recognition and machining we have in our software. By the way, I didn't change a single word. I'm just taking these sentences from that article. Okay, so basically, this growing need for more sophisticated CAM from the technology side. What does this mean? We already mentioned it the whole day yesterday. The continued increase in the use of multitask machine tools. Second, the growing demand for physics-based cutter path strategies. I will explain what they mean. And you'll see it's eye machining. Next, product design and manufacturing must respond to the trend toward more aesthetic designs. Today, designers are making something more fancy because people like to have fancy cars, fancy consumer goods, so they have to get nicer designs. And last but not least, the creative use of additive manufacturing, which obviously we are doing. So the market will place a premium on the products of software solution providers who develop and deliver. It's not enough to develop, you have to sell it, deliver it, and support it. A superior response to these drivers. SolidCAM is doing that. We'll see how. Okay, first, complex machine tools. Machine tool complexity and capabilities continue to increase, driving the need for more sophisticated CAD/CAM software. To create NC program required to synchronize, remember, multi-channel synchronization, their complex capabilities and to optimize their usage. The introduction, acceptance, and support of multitask machine tools is the dominant trend in the industry. If you didn't believe us, believe SimData. They check the whole market. This is the trend. Performing multiple operations, such as milling, turning on a single tool in a single setup, typically results, see the benefits, increased productivity, faster turnaround, reduced scrap, improved part quality, by avoiding errors in transferring components from one machine to the other. They are described in SolidCAM. Okay, while more capable, these tools are becoming increasingly complex to program and use. So to support complex machines, it's not easy. It becomes complex to program and use. So specialized software is required. Special software called SolidCAM, I add myself, is required to effectively use these multitask machines. The software defines the tool movement, simulate the operation, simulation very important, as we said, and post-process the output. In the end, we have a post-processor for these machines. Simulating movement is extremely important for an operator to visualize the machining sequences. Operator, SolidCAM for operators, right? The machining sequences avoid collisions and optimize the operation. CAM software must provide individual control of each turret synchronization, again synchronization, produce accurate cycle time calculations, sync and wait marks must be added. These are added automatically in SolidCAM to obtain the desired concurrent operation. You see, other softwares like Mastercam, others who don't have good support for Swiss, when people use Mastercam to support Swiss, what they do, they generate separate programs for the different channels, and then they add this sync and wait marks manually on the controller. No simulation. So basically, you could get the cheapest CAM software, and you could say it supports Swiss. How? You generate separate profiles, and then go to the controller and do all the synchronization on the controller without any simulation, without any checking. So that's how DelmiaCAM supports Swiss. No other way, because they don't have multi-channel synchronization. Okay, to program the multi-spindle, multi-tool capabilities of a multitask machine, it is common for the cutter paths to be programmed in the CAM system independently. Not so much independently, we do it in SolidCAM together. They are then synchronized automatically by the CAM system. That's what SolidCAM does. Manually by the programmer or combination of both. What they are saying is after we give you the automatic synchronization, you could do changes. This is the additional manual things. When executed on the shop floor, the machining begins with the sync codes orchestrating the program flow of each channel. This is done automatically in SolidCAM. NC programmers can verify the NC program and their sync codes before using them. Obviously, this is our simulation. The growing use of multitask machine will continue to drive demand in CAM functionality to support their ever-growing levels of flexibility. They are flexible and complex. SolidCAM supports them. Now we come to the second thing. What does it mean, physics-based cutter path strategies? They say end-user demand for cutter path strategies with tool motion dictated by physics-based analysis is the dominant trend in the industry. These physics-based strategies are designed to produce highly effective and efficient tool paths. On the right, this is iMachining. Significantly reducing machining cycle time, that's what iMachining does, extending tool life, and improving part quality. Now comes the next sentence exactly describe iMachining. Most of these physics-based strategies excel when machining hard materials. That's what Ken Merritt was showing us, cutting titanium and other very hard materials. Now we come to the traditional tool paths. Most traditional cutter path strategies are based on the geometry of the shape. These are the offsets that you use to do all the pockets and everything, are based on the geometry shape of the area to be machined, plus one or more geometric properties like step over, for example. Physics-based cutter motion strategies, on the other hand, are based on the way a cutting tool progresses through the material. That's what iMachining does. Every point when we progress, we do a different calculation. The step-by-step definition of the tool motion considers the area from which metal is to be removed and how the material being cut changes through the various machining stages. The resulting motion evolves by looking ahead to see what is coming up and modifies feeds, that's iMachining, step-overs, and cutting motion in response to the ever-changing material condition. I think these people just worked with iMachining and wrote all this. So software solution relies on physics-based assessment, such as ensuring constant mechanical lateral force on the tool and spindle, like we said, constant force on the spindle, or managing the volume of material encountered and removed with each movement. Now comes something else that's exactly described iMachining. Another criterion that may be employed to determine tool motion, speed, and feed is to assure that the heat generated in the primary shear zone is primarily carried away in the chip, and this is iMachining. All the heat goes away with the chip, minimizing the amount of heat conducted into the workpiece, so the workpiece doesn't have all this heat. These criteria usually result in tool paths that maximize tool in the cut time. That's what Ken was saying. You have nearly no rapid movement. Minimize wasted motion, rapid movement, jumping, reducing jumping around in pockets, and smoother running of the machine. Typically, they possess continuous tangent motion, this is iMachining, and more consistent tool load, iMachining, rather than sharp interrupted movements. Okay, so you believe now that when we say we are the future of CAM, it's here. We have already done all these things that people think sophisticated CAM needs. Now we come to another point why parts are becoming more nice and complex because of the need for aesthetic design, product design. So the trend for more aesthetic design that involves increasing complex shapes continues to drive the need for CAD/CAM software that can model complex shapes, you can do it in SolidWorks, and create sophisticated, efficient NC programs in SolidCAM. Use of analytics to create more optimal part geometry, this is like generative design, is also producing non-standard shapes required more sophisticated CAM programming and machine tools. More sophisticated CAM programming, SolidCAM, and machine tools, multitasking machines. More sophisticated CAM software is needed in both product design and manufacturing to respond to the trend toward more aesthetic design. So the more there is more aesthetic design, you'll need more SolidCAM and SolidWorks. Another important thing, additive manufacturing. The improvement in additive manufacturing techniques, desktop metal, binder jetting, very fast, is having a growing impact on the CAM market. 3D printing offers an increase in the complexity of product design. With 3D printing, you can print something you could never CNC, which increases demand for more sophisticated subtractive CAM. Through generative design techniques, these are the trend now, generative design techniques, We create shapes that could be not made using conventional subtractive machining, with CNC I mean, or are too costly to make with CNC only. So then comes the solution. 3D printing and subtractive CAM are often used in a complementary fashion. That's what we do. They wrote it. With the 3D printed components forming a base that requires subsequent CAM operations. That's what we saw in the movie. We print, sinter, and then we do the machining. Why do you need the machining? To create threads, we saw it in the movie, remove support material, break movable parts free from the surrounding matrix, right, Jörg? That's what you do all the time. Or create a required surface finish. That's what we saw also in the movie, to put the inserts there. Demand will increase for CAM systems that can program hybrid machines. Remember I said we are going to support hybrid machines, those machines that have both a milling head and a laser head that combine additive and subtractive in the same machine. Now I'm going to show you some beautiful slides from our software that does that. So, as I said, a hybrid machine here is a Philips company. Philips is the biggest house reseller in the world. They are in the US, and they have created a special branch called Philips Adaptive Hybrid, where they take a Haas machine and they add to it a Melchior laserhead. It's from Spain, this amazing product. So it becomes a hybrid machine. And we are going to do the support for it. Let's see some slides from our software. So in this case, you see this is the part that has been CNC machined, but you want to add to it this tube spine. You can't CNC it. You have to 3D print it, right? Let's see a few more slides from our software. You have now in our software special operations for this type of additive. You have here an operation called area laser aided operation. I will not go into details, we don't have time. There is an operation called geometry laser aided operation, multi-layer laser aided operation. Alex Miaznikov here is responsible for this project. Alex. Tool laser-aided operation, pattern laser-aided operation, toolpath parameters aided operation, and this is the end result. You see the simulation. This is the tube spine that has been 3D printed and added to the CNC machined part. So, again, you see on the top right, the future of CAM. One last slide I want to show you why manufacturing in the Western countries and Europe and the United States is becoming more and more important because of onshoring. In the last few years, there have been noticeable onshoring of manufacturing back to North America and Western Europe as those markets have become more efficient and labor costs in the Far East have increased. Sorry, China, your labor costs are increasing, so people are onshoring. But you are getting better salaries, that's also good. India is still cheap. You could manufacture in India. Manufacturers in North America and Western Europe have recognized that further automation, they need automation if you are going to overcome the advantage of low labor economies and supply chains, as well as logistical costs, benefit from basing manufacturing close to the consumers. An important point. Onshoring also reduces risk in the supply chain and eliminates time delays. Onshoring trend will accelerate with the strategic nature of some products outweighing dollars and cents. So, SolidCAM is sophisticated CAM. Onshoring is bringing more business. So, let's do it. Thank you.